Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Assistant Professor in the Department of Artificial Intelligence and Data Science. I teach the subject name is Data Structures using Python. Today we will discuss introduction about the trees. These are the topics are covered in the trees concept. Here, what are the basic tree concepts, basic trees, properties, representation of binary trees using arrays and linked list, operations on the binary trees, binary tree traversing technique. Next, how to create the binary tree from the in-order, pre-order and post-order. Well, coming to the trees concept, before going to trees concept, Python is a very rich language in terms of features and data structures. It has not a inbuilt data structures like dictionary, list, tuple and sets. Actually, the data in the Python programming, dictionaries, list, tuples, set, these are the different types of the data structures in the Python programming, and also having the creating the some other type of the data structures. Apart from, we are also creating our own custom data structures by using the classes. In this, we can learn the trees data structures in Python and also try to implement some example. Now today we will discuss about the introduction about the trees, how to create the trees, how to implement the trees using the Python programming language. Okay, coming to the trees, what is the definition of the tree? Here the tree is a data structure that can be defined one or more nodes that can be associate a parent-child relationship. Here, simply tree is called as the tree can be creating by using one or more nodes. That is the simple definition of the trees. In trees, one node is designated as the root node. Any tree, initially the node is called as a root node. This root node is also known as a parent node. Okay, and all remaining nodes can be partitioned into non-empty sets. All nodes can be partitioned into non-empty sets. That is, the each of the which is subtree of the root node. See this example. This is a simple tree. In this tree, 50 is a root node, 20 is the another child node, 45 is the child node. Here 50 is the root node, the 20 and 45 is also known as the internal nodes. Okay, and these nodes are connected with by using the edge. These nodes are connected to the edge. Okay, that is the definition of the tree. Here in the trees concept, we are learning some components are there. What are the different components in the tree? Here see one by one. First one is the root node, the second one is the parent node, third one is the child node, and edge. What is the definition of edge? Next, leaf node. What is the definition of internodes? First we can learn all the definitions. After that we are creating the tree. Okay, see one by one. First, what is the first one? The root node. What is the root node? Root node is a topmost node of the tree. It can be always the first node. While creating the tree, we can access each element of the tree that can be starting from the root node. In this example, the node containing the element is 50. The 50 element is the root node. Remaining all nodes are the child nodes or that can be creating by the subtree. Okay. The second one is the parent node. What is the parent node? The parent node of any node, the parent of the any node which can be reference to the current node. In this example, the 50 is the parent of 20 and 45. 50 is a parent of 20 and 45. 11, 46, 15, these three elements are parent of 20. Parent of 20. Again, in the another subtree, the 30 and 75, these elements are parent of 45. Okay. This is the parent node, and also having the some simple example. The next one is leaf node. Here, these nodes are in the tree which have no child node, no children node. There is no children's node in the tree. That node is called as a leaf node. In this example, 11, 46, 15, 30, 70. These all elements are leaf node because this element does not have any nodes. This element does not have any elements. This node does not any another nodes. This element does not have another nodes. Like this. Here simply the leaf node is called as a, there is no another child node. That node is called as a leaf node. Another definition is, what is the internal node? The internal nodes are the nodes that have at least one child node. At least one child node. In this example, 50, 20, 45, these three are the internal nodes. 50, 20, 45 are the internal nodes. Okay, that is the definition of internal nodes. Next one, siblings. What is the sibling? Sibling is in the data structure the nodes which belongs to the same parent node. Same parent, that is called as a sibling. That is called as a sibling. See this example. The nodes are A, B, C, D, E, F, G, H, I, J, K. These are the different nodes. Which nodes are the sibling nodes? For suppose here B and C are the sibling because the B and C has the same parent node. A is a parent node. So B and C are the sibling nodes. Next, D, E, F. These three nodes are the sibling nodes because B is a parent node. B is a parent node. And also G and H is a sibling nodes because G and H having the one parent node. That parent node is a C. Next, I and J is the sibling of E because E node is a parent node of sibling I and J. So these are the different sibling nodes. Here, if any tree, the node which has same parent node, that is called as a sibling. The children of parents are called as a siblings. Okay, that is the definition of the sibling node. Next one, what is the degree of a node? Here, this is the equal to the number of children that a node. The number of children's node. Suppose A having the two children's node. What are the two children's node? B and C is a children's node, and B is having the three children's node. 1, 2, 3. D, E, F is a children's of B. G and H is a children's of C. I and J is a children's of C. Okay, that is the degree of node. If any tree, the degree of node is the total number of children it has. Next one is, what is the in degree, what is the out degree, what is the depth. See one by one. Here, first see the out degree of the node. Here, this is the equal to the number of edges leaving the node. Number of edges leaving the node. This node having the leaving two nodes. This node having leaving only one node. This node having leaving only one node. That is called as a out degree node. That is leaving the node. Next one, in degree of node. This is equal to the number of arriving at the node. Arriving at node is this one. Okay. Out degree means this node having the leaving. This is the difference between the, this one is in degree, this one is out degree. Next one, depth. What is the depth of the node? Here, the length of the path from the root node to the destination node. Root node to the destination node. Root node is the parent node. This is the depth from root node to, for suppose this is the destination node, like this. This is the destination node. The depth means starting from root node to destination node. That is the tree's concept. Next definition is, what is the level of the tree? Level means A is one level, B and C is the level 1, level 2, level 3. Here in this data structure, the root node is said to be level 0. Here always the root node is level 0. Okay, and the children of first node at the level 1, children of the first node at the level 1, and the children of the node which has level 1 which will be level 2 and so on. This is the level 1, the level 2, level 3, level 4 until and so on. Okay, that is the level of the node. Here the next definition is, what is the height of the tree? Here the height of the tree is a maximum level of the node plus 1. The height of the tree containing the single node is 1, that is similarity to the height of the empty tree is 0. Height of the empty tree is 0. See one by one how to define the height of the tree. Here the A node is root node, B and C is the child nodes, D, E, F, G, H is the another level, I, J, K is the another level. The height of the tree means the maximum level of the node is, that is the plus 1, that is either incrementing by the 1, level of the 1. This one is level height 0, this one is height 1, this one is height 2, this one is the height 3. It can be approached from bottom to top. Bottom to top. This is 0, 1, 2, 3. Like that. For suppose, see on one example. This is the simple tree. This is level 0, 1, 2, 3, 4. It can be calculated from the bottom to top. That is the height of the tree. Here, any tree, the height of the node is total number of edges from the leaf node to the longest path. This is the leaf node to the longest path. If any tree, the height of the tree is the height of the root node. Simply another way it is defined as a height is the height of the tree. Okay, that is the height. Next one is depth. Already the depth is discussed in previous slide. This is the length of the path from the root node to the destination node. Root node to the destination node. For suppose the destination node is J. Simply in this example the destination node is J. What is the path? Root node, this one, B to E, E to J. Because the J is the destination node. For suppose K is a destination node, how to define? A to C, C to G, G to K. This is the K is the destination node. These are the destination depth node. Next one is path. What is mean by path? It is a unique sequence of the consecutive edges. Unique sequence of the consecutive edges. It can be required the follow to reach the destination from the given source. For suppose path means A to B, B to E, E to J. This is the one path. For suppose this is another path. For suppose this is the another path. For suppose B to I, this is the another path. Okay, that is the definition of the path. The next one is what is mean by subtree. In that subtree is in the data structure, each child from the node, that node is form the subtree. Every child node will be form the subtree in a parent node. A is the root node and BC are the child node. Again the B, D, F is the one subtree. This one is the another subtree. Now E having the another child node, so this one is the another child node. Okay, that is the subtree. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.